This video is about function notation. As we saw in the last video, a function is a special kind of relationship between two variables. This relationship is identified when you see that a value of the first variable uniquely determines the second variable. Now, typically we say that x is the first variable and y is the second variable. So y is uniquely determined by the value of x. Here's an example to help you understand that. If your sister is 2 years older than you, we can create an input-output table showing your ages at various times in your life. For example, if you are 1 year old, then your sister, she's 2 years older, she must be 3. If you are 2 years old, well then your sister must be 4 years old. You're 3, she's 5, you're 4, she's 6. If you're 11, then she is 13. If you're 16, then she must be 18. Notice that if I know how old you are, then I automatically know how old your sister is. So your age uniquely determines your sister's age. So this is a function. Because if I know your age, which is x here, then I know your sister's age, which is y here. Okay, so the first variable uniquely determines the second variable. We can represent that with an equation by writing that your sister is your age plus 2, or y, which represents sister's age, equals x, which is your age, plus 2. This is a classic algebraic equation. So y is determined by x. Now, the purpose of function notation is to emphasize that y is determined by x. So let's take a look at what mathematicians invented to emphasize the function nature of a relationship. We replace the second variable, in this case y, typically it's y, we replace y with a lowercase letter. F is the most common. It does not have to be an F, as you'll see, with F, and then we put parentheses, x, close parenthesis, next to the F. So this is read f of x. And you can think of f as standing for function, but it does not have to be an f. Function of x. So the y is a function of x. The f part of this expression is the so-called name of the function. And we can use that first letter, doesn't have to be F, we can use that first letter to identify what we're talking about. Here is an example to show you the usefulness of function notation. Suppose we have 3 different functions. Well, if you have 3 different functions, it makes sense to give them 3 different names. So we're going to name the first function f of x, and its given by the expression x plus 2, just like your sister being 2 years older than you. Our second function, so as not to get confused, we'll name g of x. G of x is 3x, which of course means 3 times x. And our third function, we'll go ahead and name it h of x, is x minus 6. So already you can see the advantage of function notation. We know that these are all functions of x. And we know that there are 3 different ones because they have 3 different names, f, g, and h. So we're going to find 1. We're going to find g, parenthesis 5, close parenthesis. We would say g of 5. Well, because g is mentioned first, that draws our attention to 3x. Since 5 is in parentheses, where the x used to be, that means we replace the x with a 5. Now, of course, if we don't put a symbol between the 3 and the 5, it looks like a 35. We have to now put the times sign because 3x means 3 times 5. And that value, of course, is 15. Number 2, f of 14. Well, because we have an f, we look at x plus 2, and because we have a 14, we put 14 where the x used to be. And 14 plus 2 is 16. And number 3, h of 2. Now, because we have an h, we look at x minus 6. Because we have a 2 in the parentheses, we replace the x with a 2. And then we subtract 2 minus 6, which is negative 4. Little vocab. These 3 numbers at the end are called function values. And the process that we just engaged in is called evaluating a function. So this is called evaluating a function. I had a teacher's aide in college who referred to this as plug and chug. So you plug in a number and then you do the work. That's the chugging part, I reckon. And then what do? We put the indicated number in place of x and do the math. Because the value of y depends on x, we say y, or more generally, the second variable, is the dependent variable and we say x, or more generally, the first variable. What's the opposite of dependent? Independent. So x is the independent variable. We can also call y the output, and we can call x the input. So we put the number for x in, we do the work, and out comes the value for y. This is the end of this video on function notation. Thank you for watching.